Okay, so we are Group 3, myself, Jaime A. Munoz Jr., and Bosco Doe for integration, verification, validation, and testing. And we are in charge of the Smart Coffee Maker project. This presentation will include the following sections. Number 1, introduction. It consists of the purpose, system overview, and the points of context. Number 2, reference documents. It consists of the project documents and the standard procedures taken. Number 3, key terms and definitions. This will have terms that were used mainly during the project and the definitions of said terms. Number 4, organization and management. This includes the organization and the responsibilities of the project. The largest section is number 5, VBT activities. This includes the concept phase, the definition phase, the design phase, implementation phase, integration phase, qualification and acceptance phase, and finally the design phase. Number 6, conclusion and discussion, and lastly number 7, which will be the references that we will touch very lightly. So introduction. Purpose of integration, verification, validation, and test processes is to assess the system through its development lifecycle. Essentially, we are going to see this product from beginning to end and ensure it is performing and the proper steps are being done throughout these 4 test processes that are included in the IBVT. This document details the different methods and procedures that will be used for verification, validation, and testing of the Smart Coffee Maker. The IBVT plan details the assigned activities to different team members that will be performed. Detailed explanation of the techniques used are addressed. Essentially, it will talk about what myself, Jaime Munoz, and what Bosco Doe were tasked to do and how we divided the work equally. These documents are reviewed by the team to ensure that the requirements are being addressed and correct. So every time that we finish a document, we go over it and make sure that it is exactly what it needs to be. And any feedback that we receive either from the team or from the professor, we address it and we correct the paper itself. So our intention was to create a smart coffee maker system that will brew a quality cup of coffee to any user settings. Artificial intelligence will be incorporated to learn user brewing habits, to clean itself, and recommend different coffee brews. Smart Coffee Maker will have the ability to connect to the internet and various social media platforms to post user brews and obtain other coffee enthusiast brewing recommendations. Essentially, this coffee maker is going to learn the user's brewing habits, and as it's done, at the user request, it's going to submit those brewing habits or brewing types up to social media, whether it be Instagram, Facebook, Twitter, etc., and make it available to other coffee enthusiasts to try it out. This will enable a form of connectivity among coffee aficionados. The AI of the system will be doing that, as well as performing routine maintenance, letting the user know about needed maintenance, not necessarily repairs, but more maintenance, and when there's low amounts of ingredients. This project contains of 2 team members, myself, Jaime A. Munoz Jr., and Bosco Doe. We have both added our point of contacts to facilitate the communication between us and ensure that the project is developed in a better manner. Scheduling, we both Bosco and myself have been pretty free throughout the development of this IBVT, with certain exceptions, including the weekends. So we've been pretty much available to each other and for the development of the project. Throughout the development of the IBVT, there were certain documents that were generated by both myself and Bosco. One was the ConOps document. It will be talked about later on in the. All of these documents will be talked about later on in section 5. They are the ConOps document, the cost-benefit analysis document, the requirements traceability by directional matrix, the requirement verification matrix, and the component test document. For standard procedures, we use the INCO's handbook, the fourth edition, and the CMMI DV 1.3. These have pretty good information regarding everything that's systems engineering, and for this particular project, we found these useful, and we're I want to say heavily, but not so much used throughout the development of the IVVT. Throughout the project, there were certain terms that were used a lot, and we found it useful for them to be listed here as they were really relevant to the overall IBVT of the smart coffee maker. For example, design definition, system requirements definition, disposal, all of these terms were used a lot in the actual document for this project. So we decided to put this in here to better let the reader know what it is that they're going to be reading about and when to expect them, and more what it's going to consist of. As a parent organization for the Smart Coffee Maker, we strive to be excellent in product and excellent in workplace management. We take all integration, verification, and validation to its full potential by using all available models and methods that are available. Development, project management, quality assurance, and configuration management will all work closely with each other to strive to deliver the best product available for the customer. We divided the team responsibilities evenly as possible. Here on table 2, we see the responsibilities and the team structure. For example, Bosco was the team leader and the planning manager. His job was to ensure goals of the project are met through other members of the team, just me because it was only 2 of us. He's also intended to define goals and determine the mission necessary to achieve said goals. Myself, Jaime Munoz, I was given the title of process manager and quality manager with the responsibilities of monitoring plans and the performance of all processes. I was also tasked to oversee all activities and tasks needed to maintain a desired level of excellence. Bosco was also the support manager, which coordinates technical information of a system and educates employees on its use. Um, I was also given the task of customer interface. My job was to be responsible for understanding and managing customer requirements and expectations of the system. In other words, all the key requirements that the customer or the user would want to have. That would be my task.
Hello, this is Bosco, and I will be presenting the ConOps, or the Concept of Operations document that we've created for the Smart Coffee Maker system. So this document we created describes the characteristics of the Smart Coffee Maker system in the viewpoint of a user. So there are a couple of elements that we propose in this document. Is the purpose, the safety, communication, and maintenance of the system. So the purpose of our system is used by the user. It can be used in the business or home. We want to include an AI in the system so it can learn the user habit, so it can predict or recommend coffee recipes to the user, so it can enhance and improve the user's interaction with the system. So safety is very important to us, and simplicity. So we want the customer to reuse our system over and over again. So it has to be simple, user-friendly, and for safety, it has to meet all of the industry standards, right? So it doesn't break. Communication is very important. If we were going to include an AI system and user interaction, we want the system to make recommendations, but with that, it has to receive updates and has to be serviced, so it can always be up to date with all of the coffee trends So maintenance is very important. We want the system to last long and that it doesn't break down when the user needs to make a fresh brew coffee uh, when they need it. So we want to constantly fix any errors that might raise up. In the Con Ops, we also provided the subsystems and the technical specification that our system will need and use. Some of the subsystem that we listed includes water storage or coffee bean storage. Technical specification. So we wanted to list out that this will be used in a standard kitchen countertop. Power is recommended as a AC power, 19 volt. Capacity is 5 gallons of water and 3 cups of ground coffee. Wi-Fi capability is needed, as long as also with a display LCD. This coffee maker shall be also NFPA and IEC approved. We now move into the definition phase where we provided the requirements that our system, the smart coffee maker system, requires. Is basically to define how our system will solve a problem, right? We want to brew a cup of coffee for the user, but how are we going to do that? So we need some requirements. So these are the top 20 requirements that we came up as a team. Things such as the system hardware shall brew both grind coffee and coffee packets. And another is the system shall have a control panel for manual use, or the system shall report data on each cup of coffee brewed to the database. This is our requirements verification matrix. We've created for our smart coffee maker system. This is in response for the requirements that we have set up previously. We have to trace these requirements and see where it is in the verification stage, such as if it's in the definition or the design or implementation, integration, or qualification. So an example that we know is that some of the key requirements, such as the hardware shall brew both coffee grinds and packet, and the system shall weigh less than 4 pounds. These requirements need to go through actual testing and integration or the qualification stages. So as you can see on our chart, is both marked that it has to be verified within those stages. We've next provided all the elements that are relating to our smart coffee maker system. And with that, we can create this system requirements bidirectional traceability matrix. So this maps the requirements to the test cases. It helps to determine if all the requirements have been covered. And as you can see, there is some elements that we have to document that we notice that the main function of this is to brew coffee. So all of the components and subsystem that are responsible for brewing are traced with a forward traceability. You can also see that other elements that enable this brewing function is for support and is marked as a backwards capability. Next is the design phase, and we've provided a cost-benefit analysis for the smart coffee maker system. is used to analyze which decisions to make and which to forego. We have summed the potential rewards for the smart coffee maker that is expected from the situation or action, and then subtract the total costs associated from making that action. We've uh, listed out 20 risks ID in this system. Things such as if the system is overweight and weighs over 5 pounds, or the system camera malfunctions and does not record the videos. Um, these are some examples we've developed as we worked on this document, and it breaks down the risks tied to creating this system. This is an example of our cost-benefit analysis for the smart coffee maker system. As you can see really quick on this chart, we provided the risks that were identified earlier. It shows the probability of the risk of happening, the severity, the costs such as appraisal costs, the impact costs, and the third-party costs. So the way we develop this chart is to look into accounts that this document was driven by severity and probability, right? So some of the risks, such as if the coffee maker overheats or the sensor breaking, we have to figure out first to gauge the overall sales of this product. Then we can figure out what is our budget. So then we can schedule some testing in priority, what's needed to negate the risk that was identified. We've identified the requirements and the risks previously for our smart coffee maker system. Now we can move into the implementation phase where we can test these requirements. So it's just a way to help us see if the design specification is met, or to see if we have to improve the quality of the system. So, for example, here, a component test. The coffee maker needs to be able to receive commands, and we'll tell it to make a certain blend with minimal error. The brewing accuracy is the focus of this test and will be measured in a number of iterations. You can see an example we provided of one such test. So the test is select coffee brew. So a tester would note down the results, right? How many times the coffee is brewed, is it within the specs or not, and any notes while the test was being conducted. Another important test is the requirements traceability. In this section we provided, it's very important because it shows to see if the test case matches with the specific requirements, such as the ability to brew coffee section is the highest of the important in this test case. The accuracy in brewing the selected cup of coffee is significant for the machine to achieve its intended goal. The accuracy of the coffee maker would depend on how effective the machine is brewing different kinds of coffee. After multiple iteration of different selections and different choices. There's some assumptions and constraints, such as the coffee maker will be freshly clean, or the coffee maker shall be new and free of other testing and wear. Provided is the example of a test traceability, such as brew coffee the memory software, baseline memory, memory utilization, and execution. We can test out multiple requirements, and we can document if it meets any of them meets the test case. So next, we provided the detailed test results, examples of our smart coffee maker system. So it's very important because the test results is what is the expected outcome of the test cases that we documented. And we have to look at these test results to see if it's passing or not. Because if it's not passing, then there's something seriously wrong with the system or something wasn't designed correctly. So these are just examples here, such as the ground coffee is loaded when the system is in brew. Is ground coffee is automatically loaded into the hopper? It's true. Is it within specs? Yes. And notes, the ground coffee is successfully loaded into the hopper to be brewed. No coffee was jammed. So this is just a type of example of what a result would be. And we have to look at it very carefully to see if it's passing and that our system would be successful. Again, testing results is very important for everyone on the project. And with every failures, it doesn't mean that it will fail completely. So an example is there's a test that failed. A water didn't reach 195 degrees, but it only happened 10 out of 100 times it was tested. So that means there's a 90% efficiency that it does hit 195 available. So for an example, if a stakeholder sees this, it fails, but there's a 90% chance that it's still working. So they would be acceptable by these stakeholders. But if it fails, we can also make recommended improvements, such as maybe next time changing the test environment or increasing the ambient temperature or increase the brewing request. So adjusting it might see different results, and then we can take that into account and determine if we want to move forward with uh, the the type of system that was used. Now move into the integration phase of our smart coffee maker system. In this phase, we've got to make sure that the smart coffee maker system is thoroughly planned. We have to provide the test procedures and also to make sure that we're testing its performance. It's important because it helps us to organize with the scheduling and responsibilities and tools and techniques that will be needed to successfully create the system. This is an example of our built-in test assessment. The purpose of this document is to provide a set of evaluations or diagnostic tests, and that it's entirely self-contained within that module it tests. So as you can see in this chart, we're testing like things such as the water level, the water temperature, or the water leaks. There's the data that we've provided and any hypothetical results. So a tester would, or the test would show the results and if it pass or fail, and then any notes that document anything that happened during this test. This is an example of our integration test for the smart coffee maker system. Basically, it's to uh, test the coffee maker's ability to perform its primary functions and all actions that come um, with the test, from the hardware behavior to the success rate that the coffee maker needs to make the intended task. So some of the requirements that we've uh, listed here, such as the system hardware shall brew coffee according to users. Is not a software, but it is relating to hardware. We've provided the qualification entry criteria for the smart coffee maker system. This is under the qualification and acceptance phase. The purpose of it is to understand and see how the coffee maker will achieve its intended goals when it's deployed and ready for user interaction. We provided the test sequence as shown here, the qualification steps, qualification test with the 6 steps, and also the testing of the exit criteria. Some of the criteria we noted, such as the coffee maker can heat the water between 100 Fahrenheit to 195 Fahrenheit repeatedly. With this exit criteria, is it completed, pass or fail, and again, any notes that may been observed when it was ran. Here we also provided things such as tools or test equipment that is needed to test some of the test cases, such as we need a stopwatch or a cell phone to be used in conjunction of testing the smart coffee maker system. We also listed the participating organization and personnel that we might be working with to get some parts certified. Sometimes a component from the field engineers or National Appliance Service Technician. They have their own requirements, and we can utilize those to make sure that our system passes those. So on here we can see the charts, the test levels that can be tested, such as test classes, general test condition, and data recording. Also, we shown you a testing schedule which details the simulation of the environment of a typical, let's say, office space that can be used. So times can be from 7 a.m. to 5, and work days Monday through Friday.
This coffee maker is used by anyone, whether it be an organization, private user, business, whose objective is to sell or consume coffee. The purpose of this project is to create a smart coffee maker system to brew all coffee goodness without the need to go to expensive corporate coffee shops such as Starbucks or Coffee Bean. This document is to document all requirements, elements, cost, and other dependencies to making this system successful. Here's a list of our references that we use to complete our IBBT of the smart coffee maker. We will not really go into these, but here they are. This is what we used for the most part. For any questions or concerns regarding this presentation, please contact Jaime Munoz or Bosco Doe at the emails or phone numbers listed previously. Thank you.